You might be thinking that why do we need vectors and matrices in neural networks? So far we did some basic examples. They were really easy. We had two inputs, x1, x2. These inputs were given to neurons, right, like this, and then we obtained our estimated y. You saw that when we were solving the neural networks, there were a lot of mathematics and a lot of equations were solved. Even though they were really easy, but solving them by hand, it was really difficult. So when we use vectors and matrices, the reason is not to make things harder. It is actually to make them cleaner and much more powerful. So when a network is very small, just like I showed to you here, writing equations is fine. For example, we were computing z1 equal to w11 x1 plus w12 x2. Then we simply did activation, which was the second step. So we obtained sigma of z, and then we repeated this for the second one, obtained the activation again, and then we obtained the output estimated function. This is really easy. But when the number of input increases, for example, we have x3, for example, we add one more neuron. So this gets more complicated, right? So we know that real neural networks have many inputs and many neurons, all doing the same kind of operation again and again. So by grouping inputs into vectors and weight into a matrix, we can write the entire layer in one line, which is written over here. So this is the equation of neural network. We remember this as a linear combination, but now it is based on matrices and vectors, right? So you see all this mathematics appear in just one equation. This single equation is doing exactly what all those individual multiplications were doing before, but this is just a smarter way. It helps us see the patterns instead of getting lost in the details. There is another big advantage, that the computers think in vectors and matrices. What do I mean by this? We know that when we do programming and coding, we have these arrays and data structures, arrays and data structures, right? So all of these actually work in vector forms, right? So the operation of matrices, the reason behind this is that operation in matrices are fast. We can do parallel computation. We can also make this W, for example, for two inputs and two neurons. This is a 2 by 2 matrix, right? Some values here. This can be scaled easily. So when we do the learning using vectors and matrices, we are not just using the notations. Actually, it is helping us to perform the approximation much faster, much easily. So when learning the language, that neural networks are actually built in, and that's a big step forward. So this is the reason we use these matrices. This is the first step, which is linear combination. And then after that, we know that we have to perform the activation, and then we have to write the estimated function, which was this way. Nothing changes, but the only change is that we have to use vectors and matrices for simplicity. And if our inputs, neurons or output increases, so it becomes more natural and easy for us to do these computations. So in the next videos, we will be using these matrices to derive neural networks.